Perfect. Yeah.
Okay, awesome. Well, I guess I'll just get started. First of all, thanks very much for inviting me out to give you a little update on some of my master's thesis research. And thanks again for the scholarship and helping fund this research. So my research was focused on post-harvest deficit irrigation in Okanagan cherry orchards. So I'll just dive right in and explain what I've been doing for the last 2 years. So what I wanted to do today was just give you kind of a quick background of the Okanagan region and cherry production, and then go into the importance of this research and what one of my main research questions was. Then we'll give you an overview of the experiment that we set up to answer these research questions and how we did it. And then I've actually completed all my statistical analysis and I'm just wrapping up my thesis. So I have a bunch of results to present, and I'll talk a little bit of some of the implications of this research. So just to give you an overview, I'm located in the Okanagan Valley in British Columbia. So it's a very hot, dry, arid kind of desert region, and we produce about 90% or 96% of the cherries for all of Canada are grown in the Okanagan Valley. And I think, can you guys see my cursor? We have 5 study sites. So there's a lake that runs down the middle of the valley, and cherries are grown kind of all the way up about as far north as our site up in Coldstream, and then further down into the Okanagan Valley. So right along the lake is traditionally where most of the fruit growing occurs in the region, and we've been able to kind of expand up a little bit higher. So this valley is all surrounded by mountains here. So these kind of blue areas, colder areas, those are more of our mountains around the valley. So the importance of doing this research, as I mentioned, with climate change, we've actually been able to plant cherries further north and at higher elevations that we ever have before. Production is just expanding in general due to the high value that farmers are receiving for this crop. And climate change is also changing the amount of precipitation that we're receiving. Our snow melt is where we store a lot of our water, and it's melting earlier. And so we've got this increased demand in August, and that's right around where we're harvesting cherries. So that's kind of why we were looking towards cherry production to save some water. So along with this increase in production, we're having a big population increase in the Okanagan Valley as well. There's a big retirement community. A lot of people are retiring in here. There's just a general increase in demand, so we need to find ways to conserve water. So what is post-harvest deficit irrigation? It's a practice that has been observed to be quite feasible in Mediterranean climates where they have a lack of water and high populations. And basically what we're doing is we're giving the trees the full amount of irrigation that they need from bloom all the way into harvest. So right when we start irrigating in about May, the trees get as much water as they need. And then after harvest, we're looking at reducing the amount of water. And so they're not receiving as much as they would typically need to not be water stressed. And you continue this practice all the way until the water gets shut off in about October, when the trees have become dormant and we get snow and they need to survive the winter. The key with this is, although the fruit isn't developing on the tree, the buds for the next growing season are being developed. So there's a possibility that there might be some effects of this deficit irrigation on the following year's crop. So one of my main research questions was, what are the effects of post-harvest deficit irrigation on both fruit quality and yield, as well as plant water status? So both while the irrigation deficit is being applied and in the following growing season. So in order to answer this question, we applied 2 different deficit irrigation treatments to sweetheart cherry trees on a quite vigorous rootstock. So Sweetheart is a very common variety planted in the Okanagan. It was actually developed at the Summerland Research Center. And it's planted on a vigorous rootstock, which means that they're quite largely spaced out, and these trees have really well-developed root systems that have the ability to go down about 4 feet into the ground. So what we did was we irrigated the trees as normal all the way until harvest. And then after harvest, we simply went in and changed the irrigation sprinkler heads. So the farmers just continued what they would normally do after harvest. And then we had a 25% reduction and a 50% reduction. And we applied these treatments at 5 different sites within the Okanagan Valley. So we had sites 1, 2, and then the group in Summerland all represented kind of a difference in latitude within the valley. And then the 3 sites in Summerland, 3, 4, and 5, were all distributed at different elevations. So we had one right down by the lake and one that was quite high up. So some of the measurements that I was taking included stem water potential. So this is an indicator of water stress. Basically, if you think trees are kind of how they move water up into the tree, it's kind of like works like a big straw. So the tree is there's a certain amount of force that's happening as the tree is sucking water up. And the harder that they have to pull water up, the more water stressed they are. So that was our first measurement. And we took these measurements for every 2 weeks from June all the way until after harvest. So we got an idea of what was happening while the trees were receiving a full amount of water, and then as well while they were receiving the deficit. And from this, we could also tell that or see if there was any effect in the following year on the tree's ability to kind of deal with water stress and make sure their vascular tissues were all still happy. At the same time as measuring stem water potential, we measured tree respiration. So trees are kind of like people in the way that they breathe in and out, except they inhale CO2 and they exhale oxygen and water. So we have a fancy gas analyzer, and you just clamp it on the leaf of a tree, and it'll actually measure the amount of and calculate the amount of carbon that's being fixed by the leaves and how much oxygen and water is moving in and out of those little stomatopores that are on the bottom of all of the leaves. From here, we can also measure what's called water use efficiency. What typically happens with plants is when they get more water stress, they close those stomatopores up and they trap CO2 on the inside, which can still be fixed by the plant, but they are actually losing less water. So we call that an increase in water use efficiency. And then we also looked at fruit quality and yield. So some of the fruit quality measurements we looked at were firmness, size, the sugar and acid content of the cherries, as well as the color and the stem pull force, which is just how well attached those stems are. They need to be well attached to make it for market. What we did is the day before commercial harvest, we went out and collected a bunch of samples. And then we took all our fruit quality measurements that same day and looked at the differences between irrigation treatments right at harvest. Then we took a batch and we put it into storage for 6 weeks. So this was done because a large portion of the cherries in the Okanagan are sent for export, and they're sent on shipping containers to China. And it takes them about 4 to 6 weeks to get there. So we wanted to make sure that once they got shipped, that we would make sure that there was still no differences in fruit quality between our deficit irrigation treatments. And then there was one more storage treatment that we did, whereas we put them into storage for 6 weeks, and then we took them out and we just let them sit on the shelf, on the counter for another 6 days. So this was to emulate if once they got to China, maybe they sat in a bit of a warm market, and then they would get bought by somebody and maybe would sit on their counter at home and see if there's any changes there as well. So this is perfect timing for your meeting because I've done all of my data analysis. We basically found that applying this deficit irrigation didn't increase water stress. So what this tells us is that farmers are probably already over applying. So they're applying above field capacity. And when we reduce the amount of water in half, the trees still have access to enough water to keep them from becoming water stressed at all. So that was a really important finding of this study. And then we also developed some thresholds, which are fairly similar to other ones published in the literature, but nice to get for an Okanagan variety in the Okanagan. So these thresholds were kind of a one-time threshold and a sustained threshold. So they can drop down to maybe negative 1.9 megapascals for a couple days, but then if you're going to apply it over the long term, they should stay above negative 1.3. These thresholds are really good for other research scientists, but there's definitely going to be some more research needed to adapt these to the farm level, because giving a farmer some stem water potential thresholds is not very practical. It's a measurement that takes sometimes up to 2 hours in the field. So there's a little bit more research, but at least it's a starting place. Then we have our tree respiration measurements. So we found that all of the measurements that we took decreased when we applied water stress. So the amount of CO2 or the amount of carbon that was being fixed decreased. Just the total volume of gases moving in and out of the stomata decreased, and the amount of water vapor also decreased. But a kind of side effect of this is that they did end up using water more efficiently. So some of that carbon was getting trapped when those stomata were closing. And so they were still able to fix that carbon and they were losing less water. So another proof that sweetheart cherries are fairly well adapted to living in a hot, dry climate. And then for our fruit quality and yield measurements, we found that current reductions don't have any impact on fruit quality or yield, but it's extremely important to keep in mind that a lot of our deficit treatments didn't actually cause water stress. So there is a potential that if we applied even further deficits and caused more water stress after harvest, that it could impact fruit quality and yield in the following growing season. This is kind of a side result that was kind of interesting. The Okanagan experienced a wicked heat dome at the end of June in 2021. And we just happened to be going out. We went out right before the heat dome and had started our water stress measurements, and we went out right after as well. So this red line here shows the day at which the water stress occurred. This y-axis here shows us water stress. So basically, as these lines go down, the trees become more water stressed. So we can see after the heat dome, they did become slightly more water stressed, but they never really dropped below any drastic thresholds. Most literature says if they stay above negative 1.5, they're not really experiencing any water stress. So even with 43-degree temperatures, these trees did just fine, and they didn't seem to cause any lasting damage, and everything recovered quite well. So another point that these cherry trees are quite well adapted to the Okanagan heat. And the same was seen with all of the leaf respiration measurements as well. Nothing was quite negatively affected by that extreme heat that we saw. And basically, in general, we saw that trees were definitely more water stressed in 2021, and this had some implications on our fruit quality measurements. So the acidity of the cherries was quite a bit higher in 2021 than 2020, and we also had higher color, which may have been attributed to the higher heat, but it's also very dependent on harvest timing, which is dependent on a lot other factors such as our labor force, disease pressure, access to water, things like that. So I just have a couple take-home messages. So we found that we can likely reduce the amount of irrigation after harvest in most orchards, but we need to establish some better thresholds for farmers so they know exactly how much. We have a pretty good idea for the Okanagan on the whole, but it would be nice to give them, to irrigate 50% of evapotranspiration or something like that. And then the other really cool thing that we learned was that how well these trees recover from extreme water stress. So that was definitely a pretty quick overview of all of my research. And I did, as I mentioned in the introduction, I did a little bit more research into the cost-benefit analysis and soil CO2 respiration. So if anybody has any other questions, feel free to ask them now if we have some time. If not, my email's there. Feel free to send me an email. And my thesis should be published at that link pretty soon. Should be defending in about a month or so. So after that, I'll have it up and published.